Hello again, I'm back. Baby. Serious with life. Want you to get distinctions. So we'll be doing another part of the Newton's law, which is the inclined plane. That time I was dealing with the horizontal surface. Now I'm dealing with the inclined plane. In the inclined plane, I have something like this, whereby I have my theta here. Like, let's just say your object, it is in a step hill, whereby it is going upward, or sometimes like it is not straight. It is like this, either like this or like this. You see, it can be two objects on the same plane, the other one pulling another one, the other one having a force applied, the other one doesn't, that they're not having the force applied, and stuff. But today I want to right now I want to show the few things you must know about the inclined before we go into the questions. Okay, so in the inclined plane it's represented like this. Like, the quotient in the inclined plane will come like this. You will see something like a greater than sign. You see, as you can see, greater than sign, something like this. So whereby here we always know it is the we will do the free body diagram on the next video. So what you have to know, we have to know that on the inclined plane we have the weight that is acting downward, which is, you have the force that is acting downward, which is the weight, and then you have the normal force that is acting that side, which is what, perpendicular. Always I said it is perpendicular to the surface, whether it is on the horizontal or inclined plane. The normal force is perpendicular, and then your weight must be perpendicular to the horizontal surface here, you see. And then what you have to know, the weight has two. Okay, the first thing that you have to know about this thing, and this is the theta, so I'm sure you are surprised when you see these two things. So no guti, the normal force acts perpendicular to the surface. And number two that you have to know, the weight acts perpendicular to the horizontal, which is this one, the horizontal. Horizontal is left to right. Okay, and then another thing that you have to know, the weight has two components. So the weight has two components. Weight has two components. We have two components of the weight, which is the what, the vertical and the horizontal component. And then the vertical component is the what, is sine theta. So I was just showing this is just for reminding you what we will be dealing with. It is this one. And so sine theta, so the name of the force that is sine theta is it is what, FG parallel. You see, FG parallel, it is the one that you're seeing here. So when you're completing you have to complete a triangle in the inclined plane, a small triangle here, whereby the theta will come here, and this one, the normal force and the FG parallel will create a 90 degrees here. Therefore we have our adjacent side here. I'll explain that. And then when it is like this, so my FG parallel is gonna be the opposite side, which is what, sine theta. You see, so the sine theta, but the FG parallel, it is sine theta. It is the part of the weight. That's why it is called FG parallel. Then we have the one for cos theta. The one for cos theta, it is FG perpendicular. You see, FG perpendicular, it is the one that is here, which is the adjacent side. Adjacent, it is cos, as you know from your trig ratios, you know that. So whenever you're dealing with FG perpendicular, you have to write cos theta. And then what you have to know, the weight is equals to hypotenuse side. So this is taking us back to trigonometry, whereby this is the longer side. So when you want to calculate the weight, you will simply say mass, and then, like, let's just say you want to calculate the hypotenuse. Let's try it. Sine theta is equals to opposite over hypotenuse. For this hypotenuse, I'm gonna use the weight that is given, so that they can find the magnitude that I wanted. So that thing is just, don't worry about it. It is a small thing. because when you do calculations, you won't need this thing. But you have to know what it is equals to the hypotenuse side, which is this one. Okay, so right now I want us to check this one. Check this one. Since you now know what the normal force x perpendicular to the surface with x perpendicular to the horizontal, weight has two components, which is the vertical and the horizontal force. Fg parallel it is sine theta, Fg perpendicular it is cos theta, and weight is equals to hypotenuse side. Let me show you something and tell you something. I want you to memorize something and learn something. Know that the normal force is equals to the Fg perpendicular in magnitude. So Fn is equals to Fg perpendicular. So let's take our thing. Check. Is it this one? No, it's not the one that I was using. So check. Normal force is acting upwards. Ne? So let me make it like this. Ne? So my normal force, it is facing like there, and there is another force which is going upward, which is Fg perpendicular. So they are equal. Remember what I was saying there with the normal force and the weight. They are equal because this one is going upward, this one is going downward. But right now, this one is the horizontal surface. In the inclined plane, the normal force is equals to the Fg perpendicular, not weight, not Fg. The normal force is equals to the Fg perpendicular. Then it will take us here. So I don't need to make another video. So what you have to know right now, it is that the normal force formula in the inclined plane, Fn is equals to mg cos theta. This is what you have to know. What you have to know, in the inclined plane, the normal force, the formula for the normal force is Fn is equals to mg cos theta. There's no need for you to say mg cos theta minus force applied what. No. The reason why I'm saying you don't have to say mg cos theta minus what, it is because the force applied, it is somewhere here. The two blocks are normally here. You have the block here and the block here, whereby there is a tension in between, and then maybe if there is no force, you can have another. Let's just say we can have another force here, then there's another one here, which is like this. You see, so the normal force is not being affected by the two blocks. So what I mean about saying the normal force is equals to mg cos theta is because the normal force Fn, it is equals to mg perpendicular, and then this perpendicular stands for what? For cos. Because check, Fn, it is Fn and Fg are in the adjacent side of the small triangle I was telling you about. So the reason I'm saying Fg, this is the same as Fg perpendicular. You see, so this Fg perpendicular takes us back where? To this side, whereby this is the adjacent side. Adjacent side, it is the what? Cos. So cos theta, it is Fg parallel. That's why I'm saying normal force is equals to mg cos theta. Just know that. Then the normal force on an inclined plane is the formula for the normal force on an inclined plane is Fn is equals to mg cos theta. You must know that. Don't confuse yourself. The normal force, the formula for the normal force on an inclined plane is Fn is equals to mg cos theta. Then you have this the culprit. We call it the culprit because this one is a problem, or a what do you call? They call it the abstract force. Abstract force. The reason I'm calling it the culprit of there is a force that is called Fg parallel. Just note this Fg parallel, it is always included in the calculation, always. So these are two things that are important that you have to know. The normal force is equals to Fg perpendicular because they are acting in the same line and they are in the adjacent side. So the formula for the normal force on an inclined plane is Fn is equals to mg cos theta. You must know that. There is a culprit or the abstract force that most of the people skip. It is Fg parallel, which is mg sin theta. I said this is the opposite side, which is the what? Sin theta. So sin theta is Fg parallel. You must always include this thing, this Fg parallel, on your calculations when you're calculating F net is equals to blah blah. On an inclined plane, always include Fg parallel. I repeat, when you're calculating for the acceleration or whatever under the inclined plane, include the FG parallel and write it as mg sine theta. It is always there. The formula for the normal force on an inclined plane is mg cos theta. You don't need to put mg what minus force applied. No. This is the inclined plane. You must always include FG parallel, which is mg sine theta, in your calculations. These are the things that you have to know. Be careful. If you forget this FG parallel, it's done. You'll not get full marks, because this one is the important thing in the calculation. That's why they call it the culprit force or the abstract force. The normal force on an inclined plane is Fn is equals to mg cos theta. This one must be always included in your calculations, FG parallel. If you don't include it, you lose marks. Okay, so thanks guys. These are the things that we did for today, the inclined plane introduction only. Then I'll do another video for the free body diagrams, and then yeah, we'll be done with Newton's laws grade 11. I'll tell you if I have missed something. Oh, there's a Newton's laws gravitational what. That one is not a problem. So okay, yeah, see you in the next video.